Okay, so we already done first part in the DC bias for the NPN and the PNP transistor already. Okay, and also for the AC, we completely done for the CE amplifier common emitter with too many details. Okay, so the next will be a common collector and a common base. We not really go in too much detail on that. We don't need that. So you get any question about the CE amplifier? Okay, so today we're talking about common collector amplifier. You understand the common collector? That means in the AC, collector will be routed. Okay, common emitter in AC, emitter will be routed. Common base in AC, the base will be routed. For the common collector, also they get the name different, but the same, emitter follower. So either emitter follower or common collector will be the same. The collector is at the AC route. That's what we already telling you. There will be a stable voltage gain. And very important thing is they get a high input impedance. Okay? And low distortion, that means less noise. So when you're looking in the schematic, you know this is a common collector. To recognize it, first thing you have to look into where is the signal applied to and where is the output of the amplifier. So for the common collector input applied to the base. However, output from the emitter. Okay. And input, output will be in phase. Okay. Either they both going up or both going down. And in this configuration, you get two capacitors, C1 and C2, that only AC coupling or DC blocking. You don't have any bypass capacitor in this common collector, okay? And also they're telling you input, output in phase. That only thing technician you need to know, okay? The thing is normally they not go into the detailed calculation. And now if you're looking into AC module, first thing this is a collector here. And the collector will be routed. That's why common collector. And the collector, you can get the same thing. Current IC going to the base. This is the base. And what is the R prime E? That means internal resistance from the base to this is the ammeter. Okay. And for the output, this is the output here. And this is the output impedance. But in this, they're using R letter E. That means AC resistance. This will be combined between R big E and RL. You see that? R big E, RL, they in the parallel. So they combine it, you can get the AC resistance at the ammeter. That will be R big E parallel R big L. Okay? And they say R in base. This is the formula how to calculate R in base. Beta times R small e. And R in total will be the same thing like common ammeter. R1 parallel R2 and also parallel with R in base. That's what R in base right here. R small e, that's what we call output resistance or output impedance equal R big E parallel R big L. AV, voltage gain, will be equal R small e divided to R prime E plus R small e. And if you want to calculate the V out, you take the gain time to the V in. Okay? That is very basically. Now, what we want you to do, you do this calculation for me. First thing they want VB, and they want VE, IE, VC, VCE, R prime E, R small e, R in base, R in total, and they want the gain, and they want the V out. You try the best to see can you get the correct answer. One of the formula I already given to you. Okay, what VB you get?
5 volt.
5 volt, yes.
5 volt. Oh, right. Okay, let's see. I need the room so I can write it down. Okay, let's see. This will be 46, 48, 46 here. Okay, so VB. Five on, right?
Yes.
Yes.
The thing I have to do it for the student cannot follow it. If they want to learn, they get a chance. VE equal VB minus 0.7. So that's easy one.
4.3.
Exactly. Okay. VBIE. I equal VE 4.3 divide to 1K, right?
Yeah.
4.3 milliamp.
Yeah.
Okay, VC
10 volt.
10 volt. VCE
5.7.
that will be VC minus VE, right?
Yes.
Okay, 10 minus 4.3.
Yeah. 5.7.
5.7. Okay, E. F R prime E. 25 divided to IE.
4.2. 5.8.
Yeah. 5.8.
Let's see, 4.3. Okay, 5.8 ohm.
Oh. It's what's ohm.
Okay, FG. R small e. That's the same thing with G out. They will be equal R big E parallel RL. So RE times RL divide RE plus RL.
Two values in parallel is like half. So is that like 500?
So basically, what the number here? 1K, 1K,
Right. So it's 500.
500 ohm. Right?
Right.
You can say 0.5 K.
0.
Right?
Yeah. 0.5K.
Yeah.
or 500 ohm. Okay, GH. F, that means R in base equal beta times G out. Beta 175. Time we get it. You can using 0.5 K or you can using 500 ohm. Okay, so now if you're using 0.5 K, okay, let's see, 175 times 0.5, you get 87.5 K ohm. I are in total. Okay, they will be R1 parallel R2 parallel R in base. This is R in base here. Okay, so they will be 1 over R1 plus 1 over R2 plus 1 over R in base. So whoever get the answer, let me know. What you get?
Um,
8.16 kilo ohm.
You say 8.16 kilo ohm. 8.16 kilo. I need to someone else verify that answer.
Yeah, that's correct.
Okay, thank you. Okay, then now you go to J. AV. Voltage gate equal big E, small e, divide R prime E plus R small e.
I got 0.98 volt.
0.98,
Yeah,
that is no unit.
yeah.
Again,
Yeah, 0.99.
okay, 0.9. 99, right? 9998, that's okay.
Yeah, it's okay. 99.
Okay, unit will be not able. So in order to calculate the VL, that easy, right? You take 0.99 times 1 volt. $0.99.
Mr. Pham, can you scroll down for a little bit? I can't see it.
Can you see now?
Thank you.
Okay, you done it? Okay, so now I'm talking to you about a common collector. Basically, they get a three amplifier: common admitter, common collector, common base. We already done for common admitter. Now we done for common collector. And if you're looking on what we're doing here for calculation, that means for this amplifier, they not gain anything. You apply 1 volt, coming out still close to 1 volt. The gain almost equal to 1. Not gain anything. However, if they not gain anything, why do we need this amplifier? You're coming in 1 volt. You're coming out 1 volt.
To suppress the noise signal.
It's because of the impedance.
Exactly. The thing is, what happened to the common collector? About the impedance.
It's high.
Impedance will be high. Okay. So when they're going to connect the signal into this amplifier, basically they don't want that amplifier loading down the signal. So that's why they need amplify with high input impedance. Even coming in, coming out will be the same signal. Okay. If they want amplify input, they better using common admitter. Okay, common admitter will be get a high gain. Okay. However, if they need amplify with a high input impedance, they can using common collector. That means they don't care about the gain. After we already did calculation, the gain for this one only almost equal to 1. Okay, common base. Okay, they already telling you common base, they will be AC routed. Okay, make sure you understand that are very, very basic for the transistor amplifier. Common emitter, common collector, and common base. The input drive the emitter and the output is taken from collector. No current gain, but has a high voltage gain. They get a low input impedance. However, they get a high output impedance. And they will be using for high frequency application. So now you can see, compare between 3 amplifier. Okay, common collector, they get a high input impedance. Common base, opposite, they get a low input impedance. However, the output impedance will be high. So basically, they depend on that condition. When designer, they design circuitry, they want low input impedance, then they can use a common base. Or they want high output impedance, also they can use common base. Okay. And also the difference from common collector. The thing is common base, they get a higher voltage gain. Okay. That's the characteristic for common base. Now, you understand the on of the one we're talking today. When you're doing your left volt, you have to deal with that. Okay, common emitter, common collector, and also common base. We don't have to memorize on the formula calculation. However, you must be understand, with what the gain is supposed to be, or how to apply input output. Now, common base, voltage gain, AV equal RC divide R prime E parallel with RE. So when you're looking into the schematic, the circuitry, in order to know that will be common base, you all the time, you must know where they apply the input and where the output will be taken. Input will be applied to emitter. Okay. However, output will be from the collector. What is the name for C2? Why do we need C2?
Bypass.
DC.
What the name
Yeah, bypass.
for
AC
C2?
coupling.
DC
Blocking.
blocking or AC coupling. Now, why do we need that C2? If we don't have a C2, is it okay or not okay?
No, it's not okay. It will be grounded.
That means you don't have any bay voltage, right? If you don't have a C2, the bay will be grounded. That means 0 volt anyway. They're not working. Okay? So you must get the C2 here. DC blocking. That means for DC they open. So you still calculate the VBB right here. Take VCC times R2 divide R1 plus R2. That's a DC bias. Okay? If you don't have a C2, that means voltage here all the time will be 0. Circuitry cannot be working. However, for the AC, then C2 will be shorted. They're telling you the bag will be go to the route. That's why we call common base. Okay. Voltage gain. Okay. RC divide R prime E parallel R big E right here. Okay. Output resistance R out. Same thing. You get this RC RL. In AC, they will be parallel. So that will be RC parallel RL. That's what you get. Output impedance or Z out. Okay.
Question?
Some different textbook, one they using R out. Okay. That means output impedance. Some textbook they using R small c. That means AC collector resistance. That's the same thing. Okay.
Does this configuration have a high output in
High
gain?
output impedance.
Yeah, but the gain is real large too, is that correct?
Exactly.
Okay,
High voltage gain. That's the only thing is what you need to memorize. Characteristics for H amplifier. You don't have a chance to go into detailed calculation. If you can do it, that means the best. Okay. C1, C2, DC blocking. And they can show you input, output will be in phase. Both going up, both going down. Only thing is, voltage gain for the common base will be higher. Okay, any question?
Yes, teacher, yeah, I have a question.
Yeah, go ahead.
Which is the best amplifier? There is any ideal amplifier of the one of the three? One?
Either one or common emitter, common collector, common base. Either one, depend on application.
Okay, depending on application. Right?
Engineer, we design the circuitry. Then we have to decide which amplifier we need. One we have to deal with the gain. One we have to deal with the input impedance, low or high. Okay, and also output impedance, either low or high. When you connect the signal into the low input impedance, that will be loading down the signal. They don't want it. So they have to select amplifier with the high input impedance.
Okay, thank you.
You're welcome. The thing is, when you be engineering, you must be design the circuitry. That's what you have to come up with detail. We are the technician. We just testing. That means they're telling you apply the input and measure the output or measure any certain point on the circuitry. If you're doing it right, you get a right answer. On the circuitry working right, something going wrong, then you cannot get the right answer. Your job will be correct it, fix it, find out what's going on, what's wrong. So the key point we'll be learning troubleshooting. That's what I save it for when we start doing the lab volt. I teach you guys, I will be helping you. When you get a problem, what can we do? Okay, any question up to this point on the common base amplifier? See, I'm talking, keep talking every day, and I try to update, improve circuitry. So that's why I still memorize, okay? Don't have to study, just doing over and over and over. Up to the certain point, you're looking into the circuitry, you know right away. That is what we want. Okay, now go ahead and try this example for me. Normally, you will be saying this will be in the assignment. On the quiz, if I asking you, I given you the formula. So you don't have to memorize the formula. However, if you get the formula, then you know how to do your calculation. If I already given you the formula, everything, and you still cannot get it, I give up. Okay, go ahead and do this for me. At least you have to do it one time. So that's why I want you to do it.
Mr. Pham,
Yes, sir.
should letter C be VE over IE or VE over RE? Letter C.
VA, you're talking about number C, right?
Yeah.
VA divide to IE. Oh, sorry. IE.
Okay. RE. Yeah. Okay.
Yeah, thank you. Thank you. Will be correct that. Okay, so basically that will be RE. Okay, let's say VB. What you get? Equal how many?
1.76 volts.
You said 76 volt.
1.76.
1.76 K volt.
You say 1.76. Right?
Correct, 1.76.
Okay, that's correct answer. You take 10 times 12K. Divide 12K plus 56K.
12K and 56 is basically 68K.
Mr. Pham, is it okay if you round it up?
Under that number,
If you round it to 1.8,
that's
is that
okay.
acceptable?
Yeah,
Okay.
normally everything they have to get the tolerance. Plus minus 10% or 5%. you cannot get identical. Exactly, no way. Depending on calculation, how many decimal you take it. So same thing, when they asking you to measure at the base, the value they want 176. However, they have to plus or minus 5%. That means 1.8 be 5, 1.7, okay. Never get exactly the value. Okay, VA, VB minus 0.7,
1.06.
1.06. Okay, IE. The reason is I want someone try to get the calculation done,
1.06 milliamps.
1.06 milliamp.
Hey, Mr. Pham, can I ask a question here?
Yeah, go ahead.
I know you like to use the formulas, but since IE and IC is so close, can you, and there's a tolerance, can you roughly say IE times RC and then take subtract that from VCC to get VC?
You're talking about IE and IC, right?
Yeah, letter D. Yeah. So I mean, because IC and IE is are pretty close, I guess. So,
Okay, that only thing they can tell you. That means they try to ignore current IB.
yeah.
The thing is IB too small.
Mhm.
Then you can using IE, IC will be the same. Okay, in this case, they suppose IE and IB will be very small. So that's why they don't want to calculate the IB.
Okay, so like I was saying, you can just take IE and multiply it times RC, and then you subtract that from VCC, and that gives
Exactly.
you VC.
Same thing.
Yeah. Okay, thank you.
Yeah. If they want IB, then they already telling you we need to calculate the IB. Otherwise, IB is small. Okay, VC, what VC equal?
7.66.
What the value?
7.66.
Okay, I'm marking here. IB close to 0. So you don't have to calculate the IB. And VCE. VC is 766 volt. VE 1.06.
That's
6.66.
minus 1.06. You get 6.6, right?
Yes.
Yeah.
Very good. 6.6 volt. Price A. 25 divide IE 1.06.
23.5.
Let's see. 25 divide 1.06. 23.6 ohm.
Yes.
In. Okay, what I already said. If I given you the formula, you suppose you get the answer. That means 23.6 divide RE 1K.
Rn has got to be smaller than R prime E. If they're in parallel.
So you get the 0.025 ohm. You just add it in.
You have 23 for
Yeah,
R,
23.1.
23.1 for Rn.
You said 23.1
Yeah,
ohm.
yeah.
Anyone get that answer?
See, because if little r prime E is 23.6, and you put that in parallel with big RE, which is 1K, you always get your answer smaller than the smallest.
Right.
So then it's got to be, yeah, like that.
RC GL, R big C parallel R big L, 2.2 times 10K divide 2.2 plus 10K.
$22.98.
You say 22.9
Yeah,
ohm,
mhm,
correct?
right. That's close.
Yeah, yes, it is.
That's good enough for government work.
I don't think that's correct.
I don't get that.
If they're in parallel, RL is 10K, it has to be less than 10K.
I got 1 point.
23.
I get 1.8.
Yes.
Okay, now we do calculation. You take 2.2 times
Times 10
10,
divide
22, 2.2
plus
plus
10.
10. That K,
1.8.
that's it.
Okay.
Okay.
Yeah, 1.82.
2.2 plus 10. Okay. Revert it. I times 2.2. And I times 10.
Yeah, 1.8.
1.8 K.
Thank you.
Yeah, 1.8.
Okay. Last one. You take 1.8 divide R prime E.
23,
Divide to 23.6.
0.07,
93.6.
What you get?
0.07.
Oh, come on.
Let me try again.
You take the RC 1.8K.
1.8.
76.
76, yeah.
Yeah, 76.3.
0.3, yeah.
So they get a higher gain.
Okay. Thank you.
Okay, that's a complete calculation for the common base. Any question?
Nope.
No. Okay. Now, next one. Darlington connection. When you see the way the circuitry look like look like that one. That's what they're talking about, the Clinton, okay, pair. The Clinton transistor. They can be manufactured with a transistor in one case. That means you can using two NPN transistor make a connection. You can get Duck Clinton. Or they can put two transistor inside one pocket. Same thing. So why do we need the Duck Clinton transistor? Why do we need it?
Higher gain.
Higher current, very high current. You can see first transistor to get a beta 1. Okay. If a beta 1 equal 100, then a second one you get a beta 200. So the gain from the input Q1 to the output Q2, they go up to 1,000. That means very, very high current gain. So when you're working in the lab,
กล้องใครคนนั้นรอดค่ะ
okay, when you're working in the lab, when you're working on the Duck Clinton, you have to must be very careful. For some reason, your scope probe draw touch into the circuitry. They can cook it right away. The thing that they will be high, very high current. You get a 1 milliamp coming in, and the gain will be 100 times 100, 1,000. You get 1,000 milliamp coming out. We're not scared for the high voltage, but we really care about high current. Okay? When it's shorted, it burn out right away. So what I want you, when you're looking into this circuitry, you know that the Linton and the one they're using for high current gate. Okay, nothing to talking about that. Only thing, when you see the circuitry, you know that the duck limited, and the purpose is they want higher current gate.
Hey, Mr. Pham,
Yeah,
I don't mean to be funny, but like, so that if they putting somebody in the electric chair, that's what they want, high current, right?
exactly.
So that they can fry them.
That is the one of the circuitry try to make more current.
I don't want to see nobody making electric chairs.
Okay, so that is completely for bipolar transistor, common emitter, common collector, and common base. Any question? If it's not, now we go to our next one. Okay. That is the one we were talking about, decibel. I understand some students, they already learned that before. However, make sure you understand it. And when you get the calculation, you can do without looking into anything else. If you apply for technician at a remote company, I guarantee they will be asked few questions regarding to the decibel. And you understand the most company in San Diego, they are defense company. That means they get a contract with the government. And any contract with government almost regarding to the communication. That means they will be using DBM no matter what. Okay. Make sure you already download this handout. That's not much. We try to get it done today. Okay. Decibel. Decibel unit is important in amplify measurement. The decibel is a measurement of the ratio of one power to another, or one voltage to another. So basically, decibel is just a ratio between the V out divided to V in, or P out divided to P in, or I out divided to I in. Okay? And they given you the formula. If you want to calculate the gain in the decibel, then they will be equal 10 times log of the AP. You understand AP? AP means the gain of the power. So AP here equal P out divide PE. Okay? And AV, they will be equal V out divide V in. So if you get the V out divide to V in, that's not the decibel. If you want to calculate the decibel, you have to put in the formula 20 times log of V out over V in. However, power only 10 times log P out over P in. And if you want the current, then they have to use the same 20 log of the I out divided to I in. 0 dB reference. The maximum gain equal a mid-range gain and assigned to be 0 dB. If you take a 20 log of 1, what do you think you get? You take your calculator, press number 1, take the log times 20.
0.
Okay, that means you get 0 dB. Now, 1 here, what that means? They will be V out divide V in. V out divide V in equal 1. They're telling you V out equal V in. So when you get a 0 dB, they're telling you input output will be the same. You apply 10 volt coming in, coming out will be 10 volt. That will gain equal 1. If you want to get a dB, and the gain equal 0 dB. So they only telling you 0 dB mean no loss. When you apply 10 volt coming in and the output only 5 volt, you lost something. However, when you apply 10 volt coming in, coming out 10 volt, you not lost anything. Okay? So the 0 dB means you get no loss. Input, output the same. Okay? However, remember one thing, mid-range gain. You must be understand what that means for the mid-range gain. Okay? Mid-range gain, that means you get no loss. Input, output will be the same. And that will be 0 dB. Okay, and the question up to this point.
If we have lost the decibel, is going to be negative?
Decibel depend on you get the power gain. That means you take your P out divide P in. If you want in the decibel, then you must be using the formula 10 times 10 times log of that ratio. Then they will be come up with how many decibel. for the voltage. You get the gain for voltage to take V out divided to V in. If they asking you, I want that answer to be in the decibel, then you must be using the formula. 20 times log of the ratio between V out to V in. Normally outside, you never see any decibel. However, when you're working in the electronic especially in the RF radio frequency, that equipment, they will be measure the decibel. Then you must be converting back into the real value. Like, for the power, they want watt, they want milliwatt, kilowatt. They don't want decibel. However, you're working in the lab, you get the decibel or dBm. Then you have to know how to convert it back to the real value. Normally, we have to deal with. Okay, that will be come up. The next one, critical frequency. This is just a very, very basically, you must understand and you must memorize. What is a critical frequency? First thing, they get a different name. Also known as cut-off frequency. That's the same critical frequency. Or they can be called a corner frequency. Or they can say break frequency. That will be the same, but they get a too many different names. Okay? And what is the critical frequency? They say at this frequency, output power drop 1/2 of its mid-range. Okay? That means at the frequency they call a cutoff frequency, corner frequency, power will be dropped 1/2. Okay? Of value in the mid-range. In the mid-range, that means they not lost anything. That's what we already telling you here. Okay? 10 watt coming in, 10 watt coming out. That's the value at the mid-range. No loss. However, at the cutoff frequency, then the power output will be dropped 1/2. Okay? That means you get 10 watt coming in, output, you can get 5 watt. Also, at the critical frequency, output voltage is dropped to 70.7% of its mid-range. That means when you apply 10 volt, okay, at the mid-range, output still a 10 volt. No loss. However, at the critical frequency, output will be going down 70.7%. That means output now only 7.07 volt. Okay? If you're doing a calculation, AV, okay, you take 20 log of 0.707. That means 70.7%. You get a minus 3 dB. That telling you what? That will be telling you at a critical frequency, the output will be going down 3 dB. dBm, power measurement. A unit that is often in measuring power is the dBm. That means you're working in the lab. When you measure the power, you will get dBm. The test equipment given you dBm. However, we not deal with the dBm. We deal with the watt, milliwatt, kilowatt. So that's why we need to convert it. Now, they said the term dBm means decibel reference to 1 milliwatt of power. So the formula, if you want to calculate the dBm, equal 10 times log of the power divided to 1 milliwatt. That's only the formula you need. When you get the dBm, you're able to get the watt, milliwatt, or kilowatt. Or when you get a milliwatt or watt kilowatt, you want to be how much dBm. This is the formula. Now, example, 30 dBm equal to how many watt? Try to understand, okay? That's a really need for the guys. Now, you can see the formula dBm equal 10 times log of the power P. We don't care what power. Output, input doesn't matter. Divide 1 milliwatt. And that equal 30. The thing is they given you 30 dBm. And now they want to know, okay, how many watt equivalent to 30 dBm. Okay, therefore, now they take a log only. So they have to take a log of this P over 1 milliwatt equal 30 divide number 10. You get number 3. Okay, then now you remove the log. Take it out. Then you get P over 1 milliwatt equal, this is a log 10. You can get 10 to the power of 3, and that equal 1,000. So P over 1 milliwatt equal 1,000. You can get P equal 1 milliwatt times 1,000. That given you 1,000 milliwatt or 1 watt. Any question on that one?
When I use the formula, I'm going to put P in milliwatt or watt, or doesn't matter.
Now the answer will be 1,000 milliwatt. If you want to convert into watt, you have to divide by 1,000. However, dBm, they deal with milliwatt, not the watt. Okay, now, in order for you guys understand or not, okay, I get that one. Do it for me. 45 dBm equal how many watt? Okay, go ahead and do it for me. If you know how to do it, that means you can understand for this thing. If I get 45 dBm, I want to know equivalent to how many watt. Is it whoever get the answer, let me know.
I got 31.6.
31.6 watt.
Yep.
I agree.
You said 31.6 watt, right?
Yes.
Yes, watts.
Okay. Any else? Whoever get 31.6 watt. At least two students already get that number. I said you have to following the example. Try the best you can do to make sure you can follow it or understand it or not. I don't want any student just what it, don't do anything. You cannot gain anything for you.
I got 31.6227766.
What, right?
Correct.
Okay, so now I can show that. Make sure everyone, make sure it's clear. So using the formula, dBm 10 times log of P, whatever P,
Over 1 milliwatt.
milliwatt equal 45 dBm. Okay, so now you take the log only. Log 10 log of P over 1 milliwatt. That equals 45 divide 10 equals 4.5. And now remove the log. P over 1 milliwatt equal 10 times 10 to the power
10 to the power of 4.5.
4.5. Okay, 10 power 4.5. What you get?
316.2.
3,
16.2.
16.2. Okay, so P will be equal 1 milliwatt times 316.2. So that will be given to you 316.2 milliwatt. You want it to be a watt. Divide 1,000. You get 0.316 watt. Is it right or wrong?
You should get 3162, right? Is that what somebody else got?
It's okay.
Hey, Michael, are you there?
Yeah, I'm here.
Did you get 31.62?
Yes, should be 31.6.
Yeah, 31.6 watts.
Okay, so I'm wrong.
Yeah, the
Hey, Mr. Pham,
10 to the power 4.5
Equal what?
equal to 31622.
That's what they given me wrong answer here.
31622.
3, 1,
I took 316.2 and multiplied times 0.001.
Over
0.001
over 1 milliwatts.
is a milli.
Yeah,
Okay,
yeah, that's right. 31622. Yeah,
okay.
yeah.
So now okay, time 31622. So you get 31622 milliwatt, right?
No, it should be 3.1622 watt, not milliwatt.
Yeah, 10 raised to the 4.5 is 31622.7766.
Okay,
316, not 3.16.
okay, 316. So this is the wrong one. You say 3,000,
316, Mr. Pham.
3.
31622.
22,
Let's see, 3,
1,
No. 31622.
31,622.
1,000, exactly.
0.7, yeah.
Yeah, that's correct. Yep.
0.7.
Okay.
Yeah, there you go. There you go.
Mhm.
There
Yeah.
you go, Sam. Right again, Sam. Having fun.
So 31.6,
31.6, yeah.
Yep.
perfect.
All right, Mr. Pham, you get your certificate.
Okay, so next Monday we'll be continuing.
Okay.
Okay, and guarantee if I given you the dBm, you're able to calculate for me to the milliwatt or what? Any question up to this point?
Do we have time to go over quiz number 3? Look like the student need the answer to it.
We're not done yet?
We did, yeah, we didn't go over quiz 3 yet. We took the test number 3, but we didn't go over the answer
Okay,
to it.
I let you go.
Okay, so we
Okay,
have a
just,
little bit.
just a minute. I stop that guy.
Yes, sir.
Thank you.
Okay.
You are welcome. Okay, now you can do whatever you want.
Thank you. Okay, so this is from the quiz 3, the answer for quiz 3. Okay, so go through it, and if you have any question or if you want me to go through it, let me know. Okay. So the answer for number 1 is A, number 2 is B, number 3 is A. Okay. So any question number 1? Number 2? Number 3? Okay, no question. Next set.
Oh, can't find my notes.
Okay, so number 4, the answer is C. Number 5 is B. Okay, any question on number 4 or 5?
Oh,
No question. Next set. Okay, so number 6, the answer is B as in Bob. Number 7 is C as in cat. Okay, any question on number 6 or 7?
no.
Okay, next set. Okay, number 8 is the answer is B as in Bob. Number 9 is C as in Charles. Number 10 is B as in Bob. So any question on 8, 9, or 10? Okay, so no question. Next set. Okay, so number 11, A as in Adam. Number 12 is D as in David. Number 13 is D as in David. Okay. So any question number 11, 12, or 13? Okay, look like everyone's good. Okay, next page. Okay, number 14, the answer is A as in Adam. Number 15 is B as in Bob. Okay, any question on 14 or 15? Okay, no question. Next up. Okay, number 16, the answer is A as in Adam. Number 17 is A as in Adam. Any question on 16 or 17? Okay, no question. Next page. Okay, so there's a last one. Okay, so number 18, the answer is C as in Charles. Number 19, A as in Adam. Number 20 is B as in Bob. So any question 18, 19, or 20?
20.
Number 20?
Oh, no, sorry.
Okay.
To me,
Yeah,
like
that's-
Bob.
Yeah, so the sum, the total is going to be just adding the power together. So power dissipation over R1, power dissipation over R2, and power dissipation of whatever it is the R is, depending how many resistors you have in your circuit.
She just wanted to pick Bob. That's okay.
Okay, B as in Bob, all right.
My paper too. Thank you.
You're welcome, thank you. Okay, back to you, Mr. Pham. Thank you,
Thank you, Sam.
you're welcome.
Okay, any question?
Hello.
Okay, if no question, then good night, everyone.
Okay, good
Good
night.
night.
Good night. Good night. Thank you, Sam.
Thank you. Good
You're
night.
welcome.
Good night.
Good night.